A thin uniform rod of length L and mass m is swinging freely above the horizontal axis, passing through its end. Right, now this is basically a rod. This is a rod and this is actually rotating about this. Its maximum angular speed is omega. That means when it is at bottom, obviously then it will be having its omega maximum, because it's energy, or as we can call it, basically the potential energy will be the minimum. Now its center of mass rises to a maximum height of, right? So from this point, right, when it is in vertical direction, vertically downward direction, so what is the maximum height? So what will happen? Let us suppose it comes to this point, right? This is the maximum it can come, right? So this, if this is the center of mass and this was the center of mass, that means this is the height, right? Now it is rotating about one of its ends. So what energy is it is having right now? Let us assume that at this point potential energy is 0, right? We can take any frame of reference for potential energy. Now at this point, this is the first point, this is the second point, right? At first point, the only energy it is having is half I omega square, right? And what is I? I, because it is a rod of length L and mass m, I about one end is 1 upon 3 ml square, right? So this entire energy will be converted into what? mgh. Why? Because right now it is having kinetic energy. When it reaches a maximum height, at that point omega will become 0, right? So at that point entire energy will be converted into mgh, or I can write h will be equal to half into 1 upon 3 ml square into omega square divided by of mg. Now I can deduct this, so this will be equal to L square omega square by 6g. That means option B is correct. Sorry, this is not option B. Option D is correct, because it is L omega. Over here we have got L square omega square, right?